Intermediate Algebra Section 2.5. If we know the slope and the y-intercept of a line, we can find an equation of a line by substituting this into the slope-intercept form. And in this first problem, they're asking us to find a linear equation. And if we look closely at the information, they're giving us the y-intercept. This point, 0, 4, lands on the y-axis, and for a linear equation, this is our y-intercept. So we then can cut to the chase and use the slope-intercept form of a linear equation, which is y is equal to mx plus b, to generate the linear equation that they're asking. We will replace m with the given value 3 and b, our y-intercept, with the given value of 4, and we have our equation. Quick and short, and it only works when we're given the special point of our y-intercept. Should they give us a little more generic information, and by generic I mean just any old point, if we know the slope of a line at any point, and this is just any run-of-the-mill point, we can find the equation of the line by using the point slope form. The point slope form of a linear equation is y minus y sub 1 is equal to m times x minus x sub 1. Well, where m is 2/3 in this particular problem, and the given point, we will replace our subscripted variables. So the equation of this line will be y minus the y value, which is a -2, the slope 2/3 times x minus the x value of 4. Simplifying this, and different problems will ask that the equation put in standard form, maybe expressed as slope-intercept form. It depends on the problem. At least we can simplify here by adding a 2, or not adding a 2, but simply replacing minus a minus with plus 2. We have generated an equation that has these given components. Should they ask us to put this in slope-intercept form, we would want to get y by itself. Before we do that, though, let's use distributive property. 2/3 times x would be 2/3 x, and 2/3 times -4, with 4 having a denominator of 1, we would end up with 2 times 4 would be an 8/3. Positive times a negative would be a negative. Now, to get y by itself, if the goal is to express the linear equation in slope-intercept form, we'd want y by itself, so we'll subtract 2 from each side. But instead of 2, if I multiply top and bottom by 3, I'm going to call this a 6/3. 6/3 is the same as 6 divided by 3, or 2. So I'm subtracting a 2, which cancels out here, leaving y. Nothing affects the x. But we have a -8/3 minus 6/3 common denominator. We can add the numerators, and instead of subtract, we'll add a negative. -8 plus a -6 adds up to be a -14/3. And I should just have one minus there. Let's cancel that out. -14/3. I could say plus a negative, and let me write that just so it's clear. -8/3 plus -6/3 is -14/3, or plus a -14/3. Both of these are equivalent expressions of this linear equation. Here it's in slope-intercept form. Here it was more in the slope-intercept form.